Okay, before we start diving into chain rule, just a quick note on notation. You'll have come across this last year, sorry. You may notice that sometimes you'll see dy dx, sometimes you'll see f dash x. The history behind it is there were two people who discovered calculus at essentially the same time, but each used completely different language. And then neither really gave up the argument for a very long time. And so the mathematical world just bounces between their notation, which is incredibly frustrating. But the important thing to remember, f dash x is a gradient function. Same with dy dx. This is rise over run, effectively. And I will use them interchangeably, and you'll see them used interchangeably in your exams. Yes?
What form of the squares?
It's the second derivative. If you differentiate again, you get a second derivative. Or, in this case here, it's f dash dash x. And that won't happen until, say, week 3 or 4. But basically, you differentiate once, and then you differentiate again.
When's our first test going to be?
So, good question. First test is this lesson, second half of Wednesday, week 3, but it doesn't count to SACE. So we're going to do a non-SACE test Wednesday, week 3 on just the 3 rules, so what we're aiming for today. Our first SAT is around week 6. Yes?
If you do delta y, delta x, does that matter?
No.
Okay.
But no one does. Be right, it doesn't matter. Alright, chain rule. So, chain rule is used to differentiate composite functions. And composite functions are rather tricky to recognize. So, composite functions are when one function is wrapped inside another. So let's just consider these two, and I think these will be on your sheet. If we have f of x and g of x, do you remember from the functions of the first semester last year what g of f of x would look like?
Subbing f of x to the x in the gx.
Good. So g of f of x is basically putting f of x into the g of x function. So that would be equal to 2x take 7 to the power of 4. So we are subbing one function into another, and we call this sort of a composite function. This next one here, if we have f of x being this cubic and g of x being the sine, what will f of g of x look like? F of g of x in this case is us putting the g of x function into wherever there is an x in the f of x function. So it would be bracket, oh I changed colour, sine x3 minus 3 bracket sine x plus 4. Quick note on notation. Do you know how that we would actually write that? Alright, how, for some, yeah, good, sine cubed x. This has the danger of us applying the 3 to the x, whereas really it applies the entire sine x function. So the way you would actually see this written is you would see it written as sine cubed x. Same with sine squared, feel free to make a note. That really means a big bracket around the whole thing. It's just the mathematicians messing with us a little bit in terms of notation. That actually does kind of help us out because that power here means we don't have to write the brackets every time. Alright. Often, for some reason, we use u as an inner function. So here, you can think of u just as f of x, and it will be the inside function. So if u is sine x, and g of x is 1 on x, can you imagine what gu would be?
1 on sine x.
Lovely, nice. So here, in this case here, g of u is 1 on sine x. Nice. Alright, so that's how we build those composite functions. Let's go in reverse now. If we are thinking of reversing it, what could we think of here as the inner function and outer function? So if I'm thinking inner function as u,
would it be x squared take 4?
it would be, lovely, x squared take 4, and the outer function, g of x, would be sine x. And are you happy that if you got that, you can see a function inside and outside and they can be wrapped together? Same here. What's the inner function? U.
2x cubed take x plus 3.
Nice, it's the whole thing. And the outer function, g of x, in our case is just root x. or root u if you like, because it's the entire function under that square root. So you're thinking some sort of shell setup. Can you put one function inside the shell of another function? This one here, messier but still doable. What's the inside function?
It's just everything inside the bracket.
Yeah, it's everything inside the brackets. So u equals, what is it? Cos squared x minus 3x, and then g of x is just x squared.
Do you need the brackets around the x?
There? No. It kind of annoys me they've done it. And the final one, you can probably guess.
6x squared taken
No.
plus 2.
Inner, and then the outer is a log x. Alright. Let's actually look at the chain rule. So now we remind ourselves how inner and outer functions look. How do we differentiate an inner and outer function? So, honestly, the best explanation of it is this. Here, would you guys be happy seeing that as the inner function? Think of it as x. If you're looking at 5x cubed, you would differentiate 5x cubed by doing 15x squared. The chain rule says you can do that, but you must throw out the derivative of the inner function. So remember this u, this inside bit, you multiply by the derivative of the inner function. So in our case here, if we have 5x cubed plus 7 cubed, we drop the 3 to the front, call 15, it becomes a 2, nice. And then we have to multiply by the derivative of this inside bit. We put a u dash at the end, which is the derivative of that u function. The u dash is, 3x squared plus 0. And then here, they've been nice. They've multiplied the 15 by the 3x squared to get the 45x squared. They didn't even need to. There is enough of an answer for you. It's differentiated. So, the fancy notation for the chain rule, I honestly think messes things up a little bit. This is probably the best notes for it. You differentiate the outer function multiplied by the derivative of the inner function. Can't remember if I put that in a sheet or not. I did. Alright. Now, the actual blue box stuff from the textbook means exactly that. It's just slightly more confusing the notation they're used, I think. If it makes more sense to you, then by all means use the blue box notation. And this rule gets a lot easier with a little bit of practice. So I'm going to clear myself some space, and you guys can flip the page, we'll practice. Alright, so, for working for these, you don't typically get points for the first line of working, but I would just do it to remind yourself of the plan. And we're certainly going to do it right at the start here. I would say at the start, or haven't dried the board off, I would let u equal x squared minus 5x plus 2. So that's just reminding ourselves that we've got this inside function that we're going to call u, and therefore f of u is u to the 99. Yeah? Because it's that u function to the power of 99. That's the sort of setup. And now if we want to differentiate this, f dash x, you can write f dash u, but f dash x is probably better. F dash x is the derivative of this multiplied by the derivative of that. So it is going to be 99 u to the 98 multiplied by u dash. And when you get a bit more practiced, you're probably not even going to write that line. But it's nothing wrong with having it right now. Now clearly we want our answer not with u's but with x's. So we're going to basically reverse that substitution. F dash x here is 99, then let's put in the original function of u, so x squared take 5x plus 2 to the 98, multiplied by, and here brackets are important, u dash if u was really complicated, we might have done a u dash line here, but I'm pretty sure we can all differentiate that in our heads. It's going to be 2x take 5. Now remember in year 11, when you saw something like this, you would have had to expand it through binomial expansion or something and then do everything individually, which was an absolute nightmare. So chain rule saves us a lot of time here. Because that isn't too bad. Clearly I've chosen an absurd number, but it makes us take this massive shortcut. So it's the derivative of the outer multiplied by the derivative of the inner. Yes?
I think you already answered it, but we don't need to simplify that any further, do we?
No. No.
Oh.
Even in exam?
Unless the exam or question implies show that, meaning show that you end at this point. So in theory, I could do, what, 198x minus whatever 5 times that is, in its own little bracket set out front of this, but they never would. You have to simplify not as much with these as you thought. Alright, here we get to one that you couldn't have done last year really. You didn't have the skills for it, but instead, let's start off with this. So that's not u is 3x squared plus 4, and therefore f of u is root u, or if you want, u to a half. Then, if we're going to differentiate, so f dash x is going to be a half u to the minus a half. Happy with that? We're just differentiating this bit, multiplied by, and this is what they call the chain rule bit, u dash. And so if I ever say you've forgotten the chain rule, this is the actual chain rule bit coming into play. Now let's stitch those components together. F dash x is a half the original u, so 3x squared plus 4 to the minus a half, multiplied by u dash, and we have u dash is just, what, 6x? And no real need for brackets. Now, this is one of those cases where the examiners could ask you to show that, and this half would combine with that quite nicely, and you might see this written as 3x over root 3x squared plus 4. And it's a bit trippy, because when you guys do the practice questions, you'll get to an answer like this and think, sweet. And then you look at the answer book, which looks like this, and think, damn it, I've done it wrong. But really, it'll take some sort of convincing, but they're the same thing. Are you guys sort of happy how that could come out? The half and the 6x gives you that 3x, and that drops that down the bottom of the square root. So it looks strange, so when you look at the answers, don't immediately think you've got it wrong, you might have got it right. Did I have another one? Yes. Alright, one more, and then we'll take a break, and you guys can do some practice of it. Okay. Anyone want to nominate the inner function here? Yeah. Typically the inner function is going to be anything under a square root or similar. So I would call that the inner function, and therefore the function will look like this. It's going to look like 3 over u to the third. So it's worth remembering that the cube root is a power of a third. This would also be 3u to the minus a third. So those skills we practiced last year at polynomials still come into play here, and we get it to this point where we feel kind of comfy we can stitch the whole thing together. So then the derivative is equal to the derivative of this multiplied by the derivative of that. So first one to start. How do we differentiate that?
3 times minus a half.
Good. 3 times minus a third, and we have with minus 1. Then u, and then what does the minus a third go to?
Minus 4 on 2.
Nice. Well done. You guys will get very good at subtracting 1 from weird fractions. Then multiplied by u dash. And really, as you get more and more practiced, you can start dropping lines out of this. This thing would be a 2-marker, worth 1 for each part at the end. These are just set up lines to help you go through it. Eventually you'll get quite quick at it. Alright, minus, use the minus 3 on 4. So that is minus bracket 2 take x to the 4, the minus 4 on 3, multiplied by u dash. U dash is the derivative of this inner. So what would u dash be?
Negative 4x to the power of 3.
Lovely, minus 4x to the 3. Clearly you can cancel the negatives and throw that to the front. Or just leave it there. Alright, I'm going to pause the recording. And we're going to have 25 minutes or so to make a start on this. Sound good? Alright, go!